Hello, everyone. My name is Kathleen Spalding from the Gurobi marketing team. Thank you for joining us for our webinar today, together with Phelas, a pioneer in innovative energy storage solutions. There will be time reserved at the end to answer questions. Please feel free to submit your questions using the Q&A feature. If we can't respond to your questions directly, we'll make sure to respond to you individually shortly after. A link to the recording along with the slides will be sent up to a week after the webinar concludes. Today, you will be hearing from Leon Haupt. Leon is the founder of Phelas and creator of Catalyst. His academic and professional background centers on energy storage modeling and optimization with experience spanning research at Fraunhofer and more than 5 years experience working on utility scale energy storage projects. Catalyst is Phelas' cloud platform for fast, transparent, and robust investment analysis in renewable energy and storage. The platform is enabled by Gurobi's powerful solver and enables complex decisions, bringing clarity to the energy transition. Also with us is Frank Hager, Senior Director for Power and Utilities, Christine Tolfik, Optimization Engineer, and Rodrigo Fuentes, Senior Technical Account Manager at Gurobi, answering questions in the background. They will address questions for Leon live after his presentation. Without further ado, I will turn it over to Frank for a quick introduction.
Welcome to the webinar, and thanks for the introduction, Kathleen. I don't need to explain more what we are going to hear. Thank you for the introduction. What is important to me is to tell you that this webinar is going to be part of our Energy Innovation series. We have just held the Energy Innovation Summit in Berlin. This is now a webinar, and Phelas and Leon previously started the engagement with us under the Energy Innovation Startup Program. So he's really making big use of our offering here. I'm Frank Hager. I'm running the energy business in Europe. So, wait a sec. In order to get you into the right mood, let's start with a little motivational video. Wait a sec. I think I will have to share differently. The sound.
Experts estimate that the world may need 30% more energy by 2050. But where will it come from? From everywhere. Everything as a grid. It will come from the sun, wind, water, and your electric cars, or from fusing atoms. Optimization is helping companies and communities to embrace the complexity, maximize resiliency, and create a greener self-healing grid. Everything as a grid. It requires innovative thinking to meet the energy demands of the future. It will improve lives and the health of our planet today, because the world's energy needs are shifting.
But what matters to me isn't.
So, short introduction to Gurobi. We were founded by Zongargu at Rosberg and Bob Bixby, for the ones who wonder why the name Gurobi, in the year 2008. We are serving more than 40 industries, but power and utilities are by far the largest. And Europe, due to the European legislation, is really leading in the sales of optimization to the energy industry. As far as our PhDs on staff, working in the R&D, working in the support expert team, or working in the technical account management team, we have 45, and we're serving more than 1,200 customers. So why the energy innovation? I mean, most of you who attend will know that math optimization is primarily for taking optimal decisions. The challenge is to respect business constraints, which are sometimes hard to retrieve. The goal is to minimize or to maximize one or more objectives. For example, satisfy the energy trilemma, which I will get to in the next slide. The solver will then find the best solution, or at least the solution close by. It will provide a proof of optimality and is technology to the rescue. And I put a little word behind that. So what was our, let's say, strategy to create this energy innovation series? I mean, the key decision-making areas in the energy transition are certainly energy security, the sustainability and affordability of energies, and this can be summarized under the energy economic trilemma. But there's also regulations, especially here in Europe, to which many or most of the public services have to adhere. So we are also integrating the regulators and the policies into our webinar series, into our summit presentations, and so on. But in order to achieve that, we are forming a community, and the community is about innovation and technological leadership. It's about collaboration and partnership, and it's about agility in a phased approach and the development of those applications. And our partner, Phelas, is right in the middle of that and is touching all of these points. So together, let's power the energy transition. And with this, I'm handing over to Leon, and I'm proud that Leon has accomplished what he will present soon.
Thank you, Frank. So let me quickly also share my screen. Oh, first and foremost, thank you very much for giving us the opportunity to speak today at the webinar and to present what we've been working on. Of course, the very core, the Gurobi solver, who has been an enabling factor for all the questions we have to answer. Today, we talk about the smart design of energy storage projects, from complexity to clarity. And well, I brought a bit of information about what we're doing, who we are, and why we're doing what we're doing. But then, of course, I want to dive into a live demo and show you how we actually solve these problems on a day-to-day basis for renewable energy developers and energy storage developers out there. And then I'm happy to dive into the Q&A in the very end. Well, let's start a bit with a problem. We see right now that we say dark clouds are rising on the energy transition, and it's actually a bit worrisome because what we see is that renewable energy projects from solar and also from wind power plants are facing major challenges. Well, these challenges are mainly because of the grid. We see that the grid limitations for existing and new projects are rising. We see congestion. We see also less grid connection points being approved. At the same time, the profitability is also becoming a problem because we have, well, simple demand and supply. We have an oversupply during times with renewable energy, mainly from solar and wind, which makes, of course, the solar prices or the prices for renewables fall. And that means that the long-term yields of these projects, which are investment projects, are falling, and we see less grid connection points. However, we need to continue the renewable energy build out in order to meet our global climate goals. The solution, well, it's who would have thought of that, is energy storage, especially co-located energy storage, which enables a lot of benefits by storing these kind of local grid charges and actually discharging when the electricity prices are high and the share of renewable is low. So that can yield to higher return on investment and, of course, a far more improved grid integration. Well, if that would be so easy, why are we not doing that? Well, the design of co-located business cases is actually one reason why it is far more complex than previous projects with only solar and wind. You need to have multi-asset, multi-size, multi-market trading optimization in order to understand what are your revenue streams. You have big uncertainty, even more than before, because you cannot predict the future, and you have to do 30 years investment horizons with unclear market regulation. And that means that there's a lot of market risk involved in these kind of projects. And what we also see when we started our company, it's powered by very limited tools. On-premise calculation, we saw a lot of Excel, and actually this graphic from XKCD is very much true that all this modern infrastructure planning is actually based a lot on very outdated, very old tools. Of course, there's great things ongoing, but we saw there an opportunity. Well, we live in the cloud computing age, and we're still using very outdated tools. So we embraced it and we developed Catalyst, which aims to be the fastest, fully transparent, cloud-enabled simulation platform in order to make multi-asset investments. And we did not start doing that. We actually started for the last 5 years developing that throughout many different consulting projects with Wien Energie, Ørsted, LEAG, and so on. And we kind of forged all this know-how of these projects into a software which now can be used by renewable energy developers and investors. Well, the very basic input-output. So of course, what does the software do? You put in different generation data. So for example, if you're planning with PVSys or other tools, you can input different data sources. You can actually put in your techno-economic data from your suppliers. If you have different offers, you can use your trusted market price forward curves, which are of course important in order to reach bankability. And then more importantly, you can also define grid congestion scenarios for your project in order to understand how would that impact the project. What we are then doing and helping is we are simulating that by using our cloud infrastructure with Gurobi as a solver at its core, where we can run many thousand scenarios in parallel, much, much faster than anything out there. And because our model is very modular, it can actually be adapted to very much every project which right now is out there. And the good thing is, because it's linear optimization at the very core, we make it fully transparent how we are modeling that. So it's not a black box. It's basically no AI at the very core. It's a very trusted, efficient optimization on working. So that's why we also can trust the results that these are really the optimal solution. And then what we provide to the user is an aggregated report, because all the data from a simulation is worthless if you do not provide proper kind of proper reports and analysis showing you why the optimum of a certain project is a given size. We provide revenue forecasts even on a monthly basis. And of course, most importantly, you can export all the financial and energy metrics into Excel, because, well, the finance world is still powered a lot by Excel, and I think there's no way around it. Everyone has their own conform audit-ready Excel tool, and of course they want to have the results. But what we are guaranteeing is that the calculation, the simulation, is actually done very efficiently. And because we are now enabling much more scenarios, you can have a far better sensitivity analysis. You can understand how different scenarios in terms of sizing of a certain project or in different market scenarios will actually perform. And we can give you more visibility in all these different project scenarios. How we do that? We actually do a quarter-hourly dispatch optimization. We are basically simulating a simplified trading, because of course for 25 years it's not possible to have the granularity as we use it day by day. But our goal is to be as close as possible to the actual trading. And that is also something where we put a lot of effort into the modeling and also discussing that with third-party traders in order to benchmark it with historic years, in order to calibrate our model, in order to make it as close as possible in this setting. Well, that was for the marketing part. Now I want to actually give you a hands-on example how that looks like. Well, since we are based in Munich in Germany, and we have started our operations of our software in the beginning of the year, we very much focus on the German market right now. But we also have done projects in all over Europe and even in South America and the US. But our kind of core focus to model kind of the German market as close as possible is right now at its core. So that's why I'm presenting today a utility scale photovoltaic plus BESS co-location project in Germany. Well, the project is simple. It's an existing PV plant, which you can choose both ways. Either you make a greenfield simulation or what is very attractive right now is also looking into retrofitting existing plants. So for example, you have here the photovoltaic plant, a 50 megawatt peak system, and it's connected to the German EEG feed-in tariff, which of course we model according to the current laws, which is that every time the spot prices are negative, the strike price goes to zero, and thus the remuneration of the photovoltaic system actually drops to zero, and it needs to curtail. So there are now different options actually to size, and you see already it's getting far more complex, because from a single line revenue model, now it's becoming a 5-line revenue model at least. So first of all, in Germany, that's a bit now the German special case. We distinguish between what we call gray and green electricity variants. So basically, whether the storage system is allowed to charge from the PV system, or it is allowed only to charge from the grid. From the grid, it would be the gray case, because the electricity from the grid is gray. And from the PV system, it would be the green case. In this case, the storage system is only allowed to discharge to the grid. This is what we are modeling accordingly. We also look, however, in a future case where we see that the storage system will also have kind of like a mix of gray and green, that it is allowed from the PV system, maybe during even technical curtailment, and is allowed to actually charge from the grid at other times. And then there are also plenty of options. Now the question is, what size of storage system is optimal for that given system at these different markets? And then there are other questions which are we usually encountering is, for example, well, is there any kind of feed-in limitation by the grid operator? Can I have charging from the grid or not? Because usually that is a grid permission problem. Or what we see now, actually day by day, we see our clients coming with all kind of requirements they get from grid operators, that they're not allowed to charge during the noontime, and they have to be so-called grid neutral or even grid friendly. And that poses, of course, a lot of challenges to the project development. And of course, that is all connected with the optimal sizing and the business case. The markets which we are looking into mainly and we're modeling is the day ahead. The intraday continues with average prices, however, the FCR and the AFR capacity. We're also working on an AFR energy module, but that is kind of more complicated, but also very highly attractive for the storage system to participate in. So what we see is the base case, the reference scenario is here, the photovoltaic system, and then the co-location case, which here in dark blue is the PV plus BESS. As a grid or as a renewable energy developer, we see kind of the following questions always popping up. So the first and foremost is kind of, can co-location improve the economic prospects of the PV project? Then, of course, the business case question, how strong is the business case for co-location in terms of net present value and IRR? And then, of course, the question is, what storage technology and what dimensioning leads to the best technical and economic performance? Because you have plenty of option in terms of power and capacity in order to size your system at that given location. And then, last but not least, the uncertainty of market and regulation. You want to know, okay, only because this scenario performs now well, the market scenarios are uncertain, and we see that usually market forecasts are usually having a low, medium, and a high scenario. We want to know how robust is that case in these different scenarios. So we see what we usually do is we build up a so-called scenario matrix. This kind of scenario matrix basically summarizes all possibilities to answer all these questions which I just mentioned. And that easily can build up really high in complexity, and it's not very straightforward to answer with conventional tools. So in this case, we have, well, now for this example, I'm selecting the gray, but in general, we can actually ask ourselves, well, gray, green, merchant, and then of course, we want to also know how would the system perform even without storage system, because that is the reference case. Then we look into different technologies. In this case, we just chose, well, lithium LFP with 15 years, 1.5 cycles, 48% round trip efficiencies, but you can type in any performance data which you have from your client or from your supplier. Then we have different storage sizes. For now, we start with a very high clustering. You can also precise them later on. When you see oh, there's an optimum between 40 and 50, you can kind of populate the optimization and see okay, I want to actually tweak the optimization to that. And then we look also only at 2, 3, and 4 hours just to have kind of a simpler first calculation. Then we have 2 curtailment scenarios, one without curtailment, and then actually we have a pattern for solar curtailment during noon hours, which is very common we see. And of course, then low, medium, and high price scenarios. And then last but not least, we can even variate the trading strategy. Are we looking only a day at intraday, or are we going full market in this gray case with day ahead intraday, FCR, and AFR? And that's already totaling over 156 simulations. And that would actually take, with conventional tools, either a lot of money or a lot of time. And yeah, well, I want to show you how we would actually build up such a case. And for that, I will actually give you a short demo. So I will quickly go here. So our tool actually provides here an interface. It's an online tool. So you log in with your account, and then you have the possibility to build up your case according to your standards. So in this case, I loaded a preset, but it's a gray co-location case where you see here the renewable generation plant. You see, well, they have 2 virtual grid connection, but actually there's 1 physical grid connection in this case, which is 50 megawatt feed in. And then because we have it gray, we give it symmetric. We also say it has a total demand limit. We also enable to actually provide own grid limitations. And we work right now with an Excel upload. So basically for each optimization, you see here, we have an Excel which you can modify with your according data. So I have here in this Excel sheet, I have different sheets. In these sheets, we provide the user the possibility to upload own data. I can here in renewable generation, I can add the different generation patterns. So for example, if you want to compare different sizes of solar system and you have different exports from PV GIS, then you can actually put them here. The system will then automatically see, okay, I see in this sheet several constellations, and calculate the business case for each variation of your PV system. The same we can do with the feed-in limit. I have here a time series with hourly time steps. I can now put in any kind of time limit I get from a grid operator and basically tell the system, please use the data from the according sheet in this Excel, which I provide to you. Well, now more importantly, we want to configure the storage system. And here, if I click on the storage system, the standard case is a no storage case. So what we are doing for co-locate case, we always calculate the reference case in order to understand what would be the revenue of that PV system without any storage system. And that is the baseline, because we are interested in this particular project. What is the revenue increase of that system? And then I have here the possibility to provide really quickly scenarios and actually add to the scenario tree the scenarios I want to simulate. The tool will then automatically build the scenario tree and actually simulate these scenarios in parallel in order to have fast results. I can even do performance sensitivities on the efficiencies as well as in the cycles. And by that, we have kind of a very, very good insight on how robust even the performance affecting the project performance. So now I'm entering that. In the next step, so for the market prices, you can here provide different scenarios. So basically, like you get them from your suppliers for time series, but also what we are providing is kind of a standard 2025, 2024 scenario. I mean, our job is not long-term market price forecasting. That is not what we are good at. We are very good in simulating different markets. And we know that all our clients, they use their own data and forecast in order to also present that to their investors and banks, because they have a strict requirement on what kind of market prices they use. So what we are doing is we're providing a platform where you can actually put in and type in these assumptions, and we will then take care of the proper simulation of the trading and the dispatch of that assets in this specific project constellation. And you see here, we have here the prices for AFR up and down, and also for FCR. And basically, then we have the option also to do a bit of kind of market settings, trading settings. As I said, well, we want to know the whole thing without the intraday and without the primary and without the secondary. So what we are then taking care of, calculating the project in all these different constellations in order to show you also what would be the project performance without the secondary market or without the primary market. And by that, you can also get a feeling how important certain markets are for your project viability. But most importantly, you want to have several different market price scenarios compared to each other. So here you can actually put in the low, medium, and high next to each other. The system will take care that all these different markets will be simulated and then run. So here then is the upload of the Excel. That is just the current state. And well, this scenario, which we have with 156 scenarios, would take around like an hour to solve. If you, of course, crank up the numbers in terms of scenarios, it easily goes to 12,000 scenarios. That might take right now up to 4 or 5 hours, sometimes longer, depending, of course, the complexity of the project. But I mean, I want to mention that here we're running several thousand scenarios in terms of sensitivity. So we get actually a really good picture of what your project performance might look like. So once this is done, and we basically have run the software and run the project, we can now go into the overview. You see here, I have a couple of projects which I'm simulating. And here, this is the project which I prepared for today. What we were missing so far is actually the cost data. And for that, we provide the possibility to, right now with a simplified, soon a bit more complex CapEx and OpEx calculation, where you can type in the according financial configuration data. So the cost, the CapEx and the OpEx of the system, the lifespan, in this case, 15 years, recapex, whether there's a recapex reduction, and then also for the renewable plant, if it's part of the investment decision. In this case, we are calculating it as co-located. So we will actually say this is not part of the investment decision. We only want to look at the storage and the revenue increase of the storage as part of the investment decision. Yeah, once this is submitted, we can actually open the report. And the report is then basically the aggregated summary of all the different scenarios. And I can show you that you can go into every detail to actually get all the nitty-gritty technical details. When you first time open it, you see actually the project layout as put in the software. And you see here the overview of all the 153 scenarios simulated. And we see on the x-axis the CapEx and the net present value. And that's why it's important that we also ask for the CapEx and OpEx data, because of course a larger storage system will increase more revenue, but there's a diminishing return at a certain size of capacity and power. The system will not yield an additional value to the system. And by that, we see here an optimum actually. And if we go to the right, we see here, this is a 30 megawatt, 40 megawatt, 50, and so on. And then we see here, the net present value is getting higher, but not linearly higher. So we see here a linear relationship and before that. More interestingly here, this would be the, in this case, I put now the CapEx and OpEx of the PV system. Here we see this would be the revenue of the renewable energy plant without any storage. So we see that adding storage to the overall project will increase the revenue and also improve the business case. So if I now click on, let's say here, this case, it's a 60 megawatt 2-hour storage system, I can get all the results from the optimization. So I go now into this specific scenario, which is in this case at the medium price level with all the primary and the secondary markets switched on. And I can see the project performance on the 30-year horizon. Of course, what I'm interested in, I want to see where does the revenue come from. For that reason, I will actually kill the CapEx. And I see, for example, here that partially the revenue comes, of course, from the EEG market, which is the dark gray in the bottom. Then I see the AFR in light blue and well, not so light blue. And then in dark blue, I see the intraday and in orange, the day ahead market revenue. And this is changing. You see here, we, for example, assumed declining FCR prices. That's why the AFR and the FCR is declining. And also you see here this decline. This is the capacity, in this case, reduction because of the degradation of the storage system. After 15 years, we have a recapex and we see the storage actually getting to its full capacity up. You can choose what kind of degradation you want to have in the system. In this case, I think we assumed 80% end of life capacity and around 1.5 cycles for the system. I can then also have like a sensitivity on the low, medium, and high scenarios in terms of how the net present value is actually changing in this specific scenario. And you see that the day ahead intraday is already very lucrative, but of course the full market day ahead intraday AFR and FCR is of course improving the overall situation, with green being the high market price, orange or red the medium, and blue the light one. So that is kind of the overall financial summary. Now we want to understand what is actually going on. And since we are simulating all these different scenarios, we can actually dive deeper into the sensitivity analysis. For that, we go to results explainability, and we can here basically plot every parameter which we have simulated. I'm choosing again on the x-axis the capex, on the y-axis the net present value, but now I want to actually color filter according to the price level. And you see here that this is the price spread in the renewable generation in the different scenarios, and then here the performance of the different storage systems in the different scenarios. I can also put it to the primary and the secondary to false. We see the net present value is still positive for all these different scenarios. And if I now want to also understand why the sizing is optimal, I can actually put in here the storage duration. And now we see in orange the 2-hour system. We see in light gray the 3-hour system, which actually here is getting more interesting, and the 4-hour system. So we have a clear trend that the 2-hour system is providing the best value at the lower capex. So that is kind of, but we can also understand how different scenarios, for example, if I choose now the high scenarios, how that might change my sizing for the better. So if I go to the low, the medium, high scenario, these numbers, of course, are changing. So if that would be still not enough, we can still also look at the power. So here now I'm putting the storage power, and we see that in this case, the 60 megawatt system is performing better than the 50. That is also consistent in also the different durations. Only here in the 4-hour duration system, the 50 megawatt system is actually performing better than its 60 megawatt system. So we can actually see trends in the sizing and actually understand why people and companies are building 2-hour or 2.5-hour systems based on actually comparison of the different scenarios. So where does all this data come from? And that is from our dispatch optimization. So I can now go also into the time series and really get down to the core of the optimization and see what is actually happening in each and every scenario on a quarter hourly or hourly basis. So now I choose basically the LFP 50 megawatt 3-hour case, and I want to see the full market optimization. And I see how the storage system and the PV system are interacting in these different markets. So here the storage system, it's a bit tricky to decipher, but this is due to the fact that we are providing ancillary services as well as wholesale market trading. So what we see here is the lower and the upper bound of the state of charge of the battery, which is due to the fact that we are providing ancillary services. And for the AFR and the FCR, we are obligated to reserve a certain amount of energy to these markets in order to always meet the criteria from the TSO. The remaining capacity can be then traded on the day ahead and intraday. And here we see that the storage system is actually consistently charging, and discharging during noontime when the prices are low, and discharging during the evening hours when the prices are higher, and by that providing the arbitrage. Here we see the EEG, which is modeled correctly according to the current legislation. So every time the market prices fall to 0, we see that the PV plant is curtailing or the storage system is charging. and the remuneration from the EEG falls to 0. And that is kind of the current state of the system. And last but not least, we can also look at the revenues and see at what time the system actually provides what kind of values. Of course, this is very abstract and it's very detailed. So that's why we also have here the option to look at the aggregated data. So by clicking here on the aggregated data, I can see the hours of the day. So for example, here, I'm now averaging through the hours 0 to 23. And I see for that specific year and the data I provided, what would be the average behavior of the storage system throughout the whole day according to each hour. And we see here very beautifully, we have the typical PV curve. We see also that in blue, this is the amount of curtailment we see. And we see that the storage system is actually consistently charging and then also discharging so charging during the day and discharging during the evening and the morning hours. Why is that? Because we have, of course, this very exposed duck curve, some call it, which has, of course, more exposed higher prices in the morning hours and in the evening hours. And we also see at what time does the AFR market provide, when does the system provide AFR values, which is typically during noontime when the prices for AFR are higher. And we see then here also the typical revenue flow of the storage system in this specific scenario, of course, providing value to the day ahead in the evenings and the morning, and more AFR and FCR during the noontime. Yeah, so this way we can also help you to really understand where this data is coming from. So this is why we make everything very transparent, and all the optimization is powered by Gurobi and our mixed integer linear programming methods, which of course are very, very efficient in order to run all these simulations so fast. Coming back to the presentation, I mean, that is a bit the fast forward of what we have doing. Usually the software is used in different states of the project. So you can answer many questions with the software. So from pre-feasibility, where the question usually is there a use case? What kind of technology, what size is interesting? But then also doing quite a proper risk assessment with many different market scenarios and trading scenarios. You can tweak the system also with different trading, let's say, weights. And of course, last but not least, to secure project finance. We help clients with our software to show investors and banks how the project is actually performing and how robust the investment will be. And you can build up kind of a very strong cases by using proper data. Usually, I always say there's always the rule, garbage in, garbage out. If you have, of course, not so good input data or weak assumptions, then of course your business case is not as strong. But of course, you can build up throughout your project. You get offers for the system. You can precise new CapEx and OpEx assumptions. And of course, you can, by that, strengthen the business case and then get it also all the way to financing. Yeah, that is basically how we help with our tool in the energy transition to build these cases. It's a very powerful platform. We're planning to expand not only from front of the meter, we're working on behind the meter modules, as well as, of course, looking into carbon capture, hydrogen, and other assets which need to be sized accordingly. The project and, well, the energy transition only gets more complex and more assets. So we are building kind of the very standard tool to help you to navigate all these different investment decisions. And by that, we hope to accelerate your project process. Well, we cannot accelerate your grid permission process, but we can definitely help you in building the business case. We can help you to find better performing project constellations, which you might not have looked into. We help to cut expenses on costly feasibility studies. And well, eventually we also encourage our clients to ask new questions which they have not been asking before, using the software to have a data-driven approach and to understand the markets better and therefore become a market leader. And that is how I want to actually end today. We want to catalyze your energy planning and our vision, make the sunshine at night. in order to have renewable energy 24/7. Thank you very much.
Great, thank you, Leon. We will now turn to our Q&A portion of the webinar. Please submit your questions using the Q&A feature located on the toolbar. And as a reminder, this webinar will be available on demand. And I see we have a lot of questions that have already come through. So if we're unable to get to your question, we'll respond to you individually after the webinar concludes. So I will go ahead and turn it over to Rodrigo.
Yeah, thank you all for attending the webinar, and also to Leon for this great presentation. So I'll start by a question from Sen Chen, which is for Catalyst. Which forecasting methods do you use, and which one performs best in general?
So thank you for the question. We are not predicting markets. That is a whole another, let's say, domain, which there are very established companies and methods out there. What we are providing is a tool to actually translate these market forecasts into the project economics and understand how technical constraints from the solar and wind and battery system and the grid connection is actually making revenue from these market forecasts. So that's why there's no intention here to provide market forecasts. We see ourselves a more sophisticated calculator helping you in translating them. All right.
Yeah, along the same line, we have a question also from Samah Al-Shahabi. So also he's wondering about what kind of other random inputs do you take into account in the models to define your scenarios? So other than the prices, do you, for example, take account of weather conditions, since we're talking renewables? Yeah.
So that is a very interesting question. So we always recommend our clients to do a sensitivity on different weather scenarios, especially with wind. That is a very sensitive topic. So we give the possibility to add different weather scenarios and even different years into the software, and by that also considering different weather scenarios. However, there is one caveat to that, which I want to highlight, is usually that you need to use one climate reference here in order to match the renewable generation with the market data. And here it's very important that you use the same year, otherwise you introduce a big error into your system. Because if you simulate that your wind power plant is actually producing at max load and the prices are really high, because the climate reference here where the market prices are based on at that time of the year is actually having very low wind generation and very high prices. And by that, there's an error. So we always kind of help our clients to make sure that they're matching these years in order to also have a more sensitivity and a proper calculation of the business case.
Great. So moving along, there's a question on, I mean, we talked primarily today, you talked primarily today on wind and renewables, solar. Is there a integration or plans for integration for other energy sources like hydrogen or gas?
Yes, especially for hydrogen and green hydrogen, power sourcing for green hydrogen, we're working on electrolysis modules where you can compare different types of electrolysis and also hydrogen storages. That is planned in the next iteration of the software, which would be, to be honest, more towards the end of the year. But that is a very exciting new area where we see our software also providing insights. The same for carbon capture and storage and direct air capture. I think that is becoming a very important topic. With the same kind of question, what kind of constellation of wind storage and direct air capture is providing the lowest costs of CO2 captured? So there's a very interesting optimization question in that sizing as well.
Thank you.
Mm-hmm.
So along the line of optimization questions, so some of the questions actually touched upon the multi-scenario, your definition of a multi-scenario analysis. So do you consider optimization under uncertainty in some kind of, let's say, scenario parameters, or it's all scenario-based and sort of handled in a deterministic way?
So right now we're using a deterministic way. We are limiting the perfect foresight, which of course is introduces an error into the optimization by actually limiting the ability of the storage system to act based on price information, which is longer than a week in the future. But I'm saying, like right now with the current optimization, it poses less of a challenge and an error. It's the same way that if I tell you you are flying to on vacation the weekend and you should charge your phone today, you will not do it until probably Friday evening because the cycle of your battery is 1 day. So right now, even if the system has the information that in 3 days there's an extreme price peak, it cannot take advantage of that. This error increases, of course, when you have larger systems. So, for example, pumped hydro or long duration energy storage system, which actually optimize for longer periods of time. And there, the imperfect foresight will become more important, but we're working actually on precising that. But right now, it poses no problem in the optimization.
Great. So in this model, there is the financial aspect of different assets, including batteries and investments. So our question is, how do you deal with the degradation, cycle-based degradation over a 25-year investment in that horizon?
Yeah, so there are different ways to tackle that. We have a cycle-based degradation method in there, which actually uses linearized cycle method. However, right now, the way most of the batteries are planned is by limiting the amount of cycles per day, and actually then also increasing or providing like a degradation penalty in order to avoid any kind of arbitrage which is too little to justify the activation of the battery. So right now, the cycle degradation is calculated purely on the energy throughput, and basically every year is basically decreased by the factor of the actual usage of the battery. So yeah.
Okay. Another question also that has to do with this revenue management aspect, with the revenue stack, is actually if you consider some sort of balancing mechanisms in your revenue stack. So the batteries in some sense are flexible assets. So maybe this could be also thought of as a balancing mechanism, but how do you also sort of see it from your point of view?
Yeah, so we have the option. We're not using imbalance information. Like you could use the battery for optimizing your imbalance position. Right now, the main use case we're looking into is basically day ahead intraday without having the kind of imbalance information. But we have done projects in the past where we were optimizing for different utilities the imbalance position using a battery. But to be quite honest, that was less profitable, at least at that time in that country, which we analyzed it. But we have the possibility, but right now it's not part of the software.
Okay, I have a question that it's more on the implementation side of Catalyst, and I think I can also include another question that we got from the audience. One is, what programming language did you use to implement this solution? And the other one is, do you have academic licenses that students perhaps can use to test and get familiar with your product?
Can you repeat the first part of the question?
The first question is, what programming language do you use to implement Catalyst?
So Catalyst was started based on my master thesis, so back then with Python, and we have now a Python infrastructure, so there's also a lot of room of improvement for the performance. Then, of course, the interface to Gurobi using Python, Gurobi then hopefully using something faster than Python. And therefore, but the good thing is that we can actually adapt and use a lot of the Python libraries, which you've seen that we're using right now. We're using Dash in order to do the visualization. And lastly, for the academic license, we have not yet provided free licenses, but we are happy to look into that. I mean, I'm a former researcher, and I started kind of this project also out of own interest to end these all qualitative conversations with a final quantitative study. And I see a lot of research potential, which now is enabled through the software. So if someone is actually looking for support in terms of doing some kind of research studies, we would be happy to help with that. So please reach out to me if you have any requests on that.
Thank you.
So after this brief break from technical questions, maybe we can squeeze in more technicality again. So there's a question actually from the audience. If you consider sort of the demand response in the sense that when you manage forecast, do you sort of take into account in the when the demand is modified in the future to sort of accommodate this change into your solution also as well?
That is touching a very interesting topic. So we're working on a behind the meter version, which basically also then takes into account the demand profile of a consumer, like a commercial industry. And as we see that with more demand side management, we see that these profiles are getting more flexible. So our goal is also to model certain kind of flexibility patterns within the demand side management. For starters, we use a static demand side demand profile from clients, but we develop different, let's say, electrification scenarios, because of course you have to take into account if you work with an industry which has a certain ambition to decarbonize, that of course the electricity demand will change in future. But right now, this is a very interesting question. I would actually cannot give a full answer to that, so we're not considering that. But I would be very delighted to dive deeper into that topic. Yeah.
Great. One question here is, can you use Catalyst to conduct evaluation of an LDES under the current market constructs that you manage?
So this tool, maybe to give a bit of a brief history of Phelas. Phelas was founded actually in the year 2020, back then with the ambition to build and develop a long duration energy storage system, which we're still doing, but we are now actually have two separate business units. So the tool was actually built out of the necessity to model long duration energy storage business cases. So we have actually in the work a module for 24/7 renewable PPA. That was kind of like the starting point when I started developing the software to show how LDES can help us to tweak out the last 10-20% in a renewable energy system. The problem, however, is that current market mechanisms, as we see it with day ahead, intraday, and so on, they're not incentivizing long duration enough. But if we introduce, and I saw, I think somewhere a question, capacity markets, if we actually introduce capacity markets into the equation, so for example, giving larger duration systems a higher yearly remuneration for being kind of for resource adequacy, then we see that the business case of long duration is already kind of improving, I would say. If you really want to meet kind of like a base load demand, you will need long duration in order to kind of get the last percentage of security for that. So we have the possibility to model different LDES technologies in the solution. Yeah.
Kind of actually answered one of the questions in the chat about including capacity market. So
yeah, exactly. I saw that already coming. Yeah.
Yeah, and there is another question actually, if also you are able to accommodate repowering in the sense of stack replacement.
In a simplified manner right now. I mean, right now we consider repowering as an option always on a 30-year horizon. especially when you co-locate it with renewables, PV and wind usually have 25 to 30 years of project horizon. The battery only up to 15, or at least lithium-ion batteries. Other technologies, they have longer lifespan on that. So of course, in order to make a kind of apple-to-apple comparison, you need to do repowering in order to also compare different technologies. Yes.
Okay, we have a question here from Gianluca, which is he would like to better understand the control logic of what is done in the day-ahead optimal control in reserves, and how this day-ahead established baseline changes when accounting for FCR and AFRR.
So the optimization on the day ahead is it's a very simplified optimization. I can say that of course the day ahead is very well predictable, so that's why we can assume that the prices are achieved also because it's a clearing price system. In the very moment we activate AFR and FCR, we see that it kind of pushes away the day ahead, especially right now in the current market settings, especially in Germany with a very high and very dominant AFR market. That kind of leads to a higher activation, and usually traders, they are trying to first fill the AFR and FCR, and then actually doing the rest on the day ahead and intraday. So that is kind of the trading logic as of now. That might change in future if, for example, the prices for AFR and FCR are changing, for example.
Great, thanks.
Regarding also future predictions, so I have a question from Tommaso Gora. Excuse me if I'm misspelling that. He's asking, which market data do you take as references? So is, for example, 2024 or an average on the previous 5 years, or forecasted markets in the next 5 years?
So that's the thing, like we don't do market price forecasting. I mean, we're doing benchmarking and backtesting for the 2024 and 2023 years in order to have a kind of like a reference which we can compare to actual traders. Usually our clients, they have their own market price forward curves. They are either buying them from third parties or they're developing them themselves. So this is a very important aspect, because this is building up the trust in an investment, that they kind of use their own market assumptions. We have no intention to build up this kind of market price forecasting ourselves. We rather focus on the proper dispatch of that.
Thank you.
Do we have time, Kathleen, for another question?
Yes, we do.
Okay,
Right.
so this is a question more on the implementation and the tool itself from Tao Chen, and that is how long does it normally take to run a typical set of scenarios? How many scenarios do you consider, and how long usually does it take to run this end to end?
So the case which I shown, which had like maybe I can quickly share my screen one more time, just to have a bit of a reference. So this case, only the orange ones, which might be a bit little to see, these are 156 simulation, each for 30 years on a 50-minute basis. That will take roughly 1.5 hours in the commercial state of our software. If you have, of course, like an entry stage, we will not give you as much resources on that, but we can see that we can even scale the infrastructure up and make that even faster in future. So yeah, that is still the time you need in order to process all this information. One case like that also has roughly a couple of 100 gigabytes of data produced, so we will also take care of all the processing in the background in order to make that in this aggregated report. Great. Great questions.
Yes, thank you all for joining us today, and thank you again to Christine and Rodrigo, but a very special thank you to Frank and Leon. It was a pleasure to have you both. This was impressive, and thank you for your work with Gurobi. Just a reminder, you'll receive a follow-up email with a link to the recording, a copy of the slides, as well as links to additional resources up to a week after the webinar concludes. If we were unable to answer your questions, as I know there were so many questions coming through, we will reach out to you shortly. And please take a minute to participate in our survey at the end of the webinar. We would really appreciate your feedback. Let us know if you think there's anything we can improve on and what topics you would like to discuss in the future. Thanks again, and we hope to see you at our next webinar.
Thank you.
Thank you.